This method it's help us prototyping simulation to load few levels of the tree, create constraints, check if everything work okay. But when we will simulate a lot of trees, we don't want to think about if it enough this separation, if enough these objects here, enough the constraint to cover all the tree. We need to switch tree and it automatically should simulate. And there is another method how to achieve this. And we will use all tree for it. We will do the same thing like here in for each, but applying for all tree, because we still know all these root points and we can find the connection points to each of these points. And let's isolate our ends. Let's copy it. So now we have all root points that we want, and we have npt here. It's assigned here npt endpoint id. So next we create a lookup, but different. Here we use PC open and use a point number, but for now it's not needed because we will use ID attribute for all three and save to npt this ID attribute. Let's create point triangle and plug it here and plug our tree here, and we will use a near point function. So type int pt equal near point 1 and current position. So now each of this point found the closest one in the tree, and it's exactly the point it's connected. So we now don't worry about it, it's find some point out this position. And type integer at npt equal point point 1. We take ID and our found point npt. And now let's check. We have our npt for all these our branches, and we need to just copy this npt to our tree. And let's copy this one, take our tree and copy. So it's the same, we use ID as matching attribute and just copy npt and do it like this. Yeah. And let's check. So we have our npt on our ends group and it's -1. And next what we need to do the same trick but for all three. Let's again isolate our ends and take this triangle because it will be the same, and we have our constraint points attribute. And let's copy back to all our tree. And just check here const. So we not use a match attribute, so it's automatically assigned this attribute to all points. And let's create attribute. Oops, sorry, I will use my script. Oh, okay. Just create a null. Need to update my script for creating outs. and type out our tree. And let's move it here. So we need this one as well. So we pin the same points, and let's copy our dot network. Let's dive inside and remove all these objects and remove here. And here we will use our tree. And here in constraints we will use our base geometry for ends and the base geometry for points connection, because we have only one geometry. We need to change here our tree. So we're pointing to the tree, and let's check. Yeah, so we have all constraints and it's updated. Let's simulate it and see if it's working. Yeah, it looks like nothing falling down. Just want to remove guides because it's a little bit slow simulation. And we have a lot of branches, so yeah, it's a little bit longer, but it looks the same like our previous setup, but it's more procedural, because if you switch tree here, the skeleton of the tree with different hierarchy and different position and different, so it's automatically update all attributes and simulate it. So you easily can simulate a lot of trees without thinking, do I need to add more this separation stuff, and do I need to add more wire objects here? And let's add another stuff that I forget. We need to copy this node end and paste it here and remove delete. So we here use only our ends point, and we should delete all these points from here, because it will look in to the closest point and it can find the same point like this one. So it's like a safe option to not take the same point.